picking up where we left off, our two angles were 30 degrees and 330 degrees. In radians, that is pi over 6 and 11 pi over 6. And since the directions say solve, we need to list all the angles for which this is true. So we would need to add 2 pi n, where n is an integer, each of those. Pause. Last one. We know that alpha and beta are in the first quadrant, so I drew two first quadrants. Alpha has a sine of 3/5. And so we can do a right triangle with a hypotenuse of 5. So do the Pythagorean theorem. 3 squared plus, call this b squared, equals 5 squared. 9 plus b squared is 25. B squared is 16, and so b is 4. Cosine of beta is 5/13. Adjacent over hypotenuse, if you use the Pythagorean theorem in the same way, you'll find that that side length is 12. So we want to find the sine of alpha plus beta. Let's use the first sum formula. So this will equal the sine of alpha times cosine beta plus cosine alpha sine beta. The sine of alpha is 3/5. Cosine beta is 5/13. Cosine of alpha is 4/5. And the sine of beta is 12/13. Multiply our two fractions. And then add them together. 15 plus 48 is 63. You have 63/65. For the final part, we'll use the fourth formula. Cosine alpha cosine beta plus sine alpha sine beta. And so we have cosine of alpha, which is 4/5. Cosine of beta, 5/13. Sine of alpha, which is 3/5. And the sine of beta, which is 12/13. 4 times 5, 5 times 13. Multiply. We've got common denominators, so let's add those together. 20 plus 36 is 56. And so we have 56/65. And that's all.